All right, well, good evening, everybody. Looks like it is time to start, so we'll go ahead and get going just so we can get into the material that I have for you guys. And if you have any questions, of course, you remember that you can submit it in the chat box, or you, at some appropriate time, you can take yourself off mute and just let me know. The first thing I want to do is just go over some admin stuff. Tonight is when I would like for everybody to have the honor lock trial done by 11:59 tonight. Okay, so please take care of that as soon as you can. Now, I talked to the folks at the Home Science Tools. If you were aware, the sodium hydroxide, the 2-gram bottle of sodium hydroxide was back ordered, and they weren't looking to have that available anytime soon. But you can order the sodium hydroxide. It's not the 2-gram bottle anymore. Now it's a 30-gram bottle. But at the end of the course, I'm going to have you guys come up with practical things you can do with the leftover chemicals and the equipment that you had to purchase. Is actually going to be kind of like an assignment. And part of the reason why I chose, almost all of the equipment and chemicals you had to purchase is because they actually have uses, just normal kind of household uses. And so, you might have to buy a little bit more sodium hydroxide than you would have originally, but it's going to be useful for you even outside of the class. So it is available if you haven't purchased it yet. So go take care of that as well. Pardon me. Okay, so the next thing I want to do is I want to show you some additional tutorial resources that I like. This is from a Google Doc that you can find in Course Home and in the Course Admin Documents folder. But let me pause this share and I'll bring up the, I'll bring it up on the screen for you guys to see. Let's see here. Okay, so now you should be able to see this document. And again, the link to this Google Doc is in that folder, Course Home and Course Admin Document folder. And it gives you several YouTubers that I think are pretty good. Of course, there's a lot of chemistry YouTubers, but these are the ones that I think are the most beneficial for you. Melissa Maribel, Boiling Chemistry. She's very good. She makes a couple mistakes in a couple videos, and she doesn't have as much content as some of the others, but I highly recommend hers. Boiling Chemistry, this guy has got a lot, and he's really funny. So that might interest you. This site right here, Bozeman Science, AP Chemistry, also very comprehensive, and so a lot of videos there that I think you'll find helpful. Fuse School is also very comprehensive, but it might just be a little too much. There's more, definitely a lot more videos than you could ever watch, and some of them are not going to be related very directly to what we go over in our course, but nonetheless, it's a good resource. Tyler DeWitt is another YouTuber. He's been around for quite a while, and he makes a lot of good videos. The thing about some of Tyler's videos is they get a little bit long. I think, when you're looking for a YouTube video, you want it to be less than 10 minutes. Some of Tyler's videos go a little bit more than 10 minutes. And so, again, just, whatever works for you. Crash Course Chemistry is good. But the thing about Crash Course Chemistry is it's usually a little bit generic. This is a good place if you just look for background or context, not so much for learning how to do calculational kind of problems and that kind of thing, but definitely good at explaining concepts, giving you general background kind of information and context. And then, so those are the YouTubers that I recommend. And then if you want to just go to a website that can give you random problems on a lot of different topics, here's one from Science Geek. It's a website, and you just pick a topic and it will randomly give you some problems to kind of gauge your readiness on any particular topic, okay? All right, so I wanted to show you that. All right. Okay, so we're back in the PowerPoint here. Also wanted to, I won't go there, but just to kind of save time, but I have also posted a Unit 1 practice quiz and key. Now I'll tell you this, the format of the practice quiz is different than the format of the actual quiz you're going to take. But again, it's a really good sort of readiness check. So when you think you're ready to take the quiz, do the practice quiz first and see how you do. make sure you give yourself enough time before the due date of the actual quiz, but it's available for you. And I generally will do this for all of the units, give you a practice quiz and a key. So the course home, and then in the folder for unit quizzes, but then there's a separate folder inside there for practice quizzes. All right, so what I want to actually do is, there was one question about a lesson, one of the questions in lesson 2 from unit 1, I want to go over, but then we'll do some Chem 101 questions in the extra practice assignment. So if you want to get that ready. But again, what I want to do first is look at one of the questions let's see, so I don't need that anymore. We'll go here. Okay, so share this screen now. Okay, so you should see sort of the landing page to begin unit 1, lesson 2. So I'm not going to do all these problems, but I just wanted to talk about one that I've been getting some questions on, and that is question number 5 down here. Okay, so it's a unit conversion problem. So I'll just talk about how to do it. One thing I will say is that some of you may have gotten it wrong on your first attempt, because I had the range of acceptable answers set a little bit too tight, perhaps. So I went in and I expanded that range of acceptable answers, and so that may have affected your score. But just in case that's not the reason why people are confused about it, I just wanted to go over it real quick. All right, so let me just get my marker ready here. Okay, so like I said, this is a unit conversion problem, and what you're asked to do is to convert 1 psi into units of kilogram per centimeter squared. So we're going to start with the 1, and remember the psi stands for pounds per square inch, okay, per square inch. All right, so remember that whenever you've got exponents in your units, you have to deal with that in a particular way, and so we'll illustrate that here in this solution. So one thing that you want to do is to get rid of these units and get the desired units. So we're going to use 2 conversion factors to do that. I'm going to use one conversion factor, this equivalency right here, which says 1 pound is 0.454 kilograms. And so I want to get rid of pounds, so that's what's going to go on the bottom. So 1 pound, and that is equivalent to 0.454 kilograms. So now my units of pounds cancel, and I have units of kilograms. So I'm halfway there. I've got the kilograms, but now I need the centimeters squared. And right now I have inches squared. Okay. So the way that I do this is I do it one step at a time, just to make sure that everybody can follow along. Because this is inches squared, that's like, that's the same thing as saying inches times inches, right? And so each one of these inches needs to get canceled out. And so we'll do it once, and then we'll do it again. Okay, we're just going to multiply the same conversion factor in the mix twice to cancel out the inches both times. So we're going to use this conversion factor to do that. So again, I want the desired units to not cancel, but I want the initial units to cancel. And so that is going to mean 1 inch on the top, which is 2.54 centimeters on the bottom. So now inches and that squared part cancels, but I still have one of those 2 inches there. So you can think of it as like I cancel that one, but I still have this one. And so I just have to do the calculation again, 1 inch over 2.54 centimeters. So now that inch cancels with that inch, which cancels the whole thing. And so now if you look at the units that you have left over, okay, you've got the kilograms, and then you've got centimeters times centimeters, so you've got centimeters squared. Okay, and that's what you were asked to do. So if you punch all those numbers into your calculator, you get 0.454 divided by 2.54, enter, and then divided by 2.54 again, enter, and you get 0.0704. Now, the other tricky thing is, and I probably should have changed this a little bit. So this makes it look like there's only 1 sig fig. Okay. So it would, if you put for your answer 0.07, that is perfectly acceptable because of the way I wrote the given information. What I probably should have said, because I usually like to see at least three, around 3 sig figs, so I should have probably said 1.00 psi, but and that would be 0.0704. Okay. All right, so that's how you do that one. I've lost my chat box, so let me bring that back up just to make sure that nobody's asking questions that I can't see. It doesn't look like it, so that's good. All right, so let me clean the screen off. Okay, and so now what I'm going to do is I'm going to go back to the Chem 101. Okay, so now we're looking at the extra practice assignment for Unit 1 in Chem 101. I had a couple people send me questions from this assignment that they wanted me to go over, and then I just picked out a few other ones, and we'll go through them in order that I have them. So the first one I want to look at is number 32. Okay. So number 32 says, the distance between centers of 2 oxygen atoms in an oxygen molecule is 1.21 times 10 to the minus 8 centimeters. What is the distance in nanometers? Okay, so one thing to just keep in mind, just to kind of make it real clear what we're talking about here, is that an oxygen molecule is O2. This is what you breathe. Without oxygen, we would all die, right? So what that is, that's 2 oxygen atoms, and they're connected. So there's this bond between the 2 oxygen atoms. And so they're saying that the bond length is 1.21 times 10 to the minus 8 centimeters. And what we want to do is we just want to convert that into nanometers. Okay. So let me just illustrate how to do that with this particular setup. This is something that I like about Chem 101, but it does take a little practice to learn how to do it in the assignment. Okay, so you always start with the number that you're given, oops, which is not that one. It's actually 1.21 times 10 to the minus 8. There it is. Okay. And the units are centimeters. Okay. So one thing we can do, and this is a common approach, is just go ahead and change this unit to the base unit first. And then we'll go from the base unit to the desired unit, to the new unit. And so that's how I'm going to approach this. So the base unit for length is meters. So I want meters on top, and I want to cancel centimeters. So I put that one on the bottom. And so now I just need to know the numbers. Well, there are, let's see how they've done it here. So there are 100 centimeters in 1 meter. Okay. So that gets rid of centimeters, and now I have units of meters, but I need to go now from meters to nanometers. Okay. So now I want meters to be on the bottom because I want meters to cancel, and I want to end up with units of nanometers. So how many nanometers are in 1 meter? Well, the prefix nano, N, that's a billion. Okay. So we want to put that multiplier in there. So 10 to the 9th, that's a billion nanometers are in 1 meter. All right, so if you look and see how your units cancel, and I like how Chem 101 does this, it cancels the units to show you, you've set it up correctly, and you get units of nanometers. So we go ahead and plug in that, and then if you see all the numbers actually right here in this bar, and you can just type all that into your calculator. So 1.21 times 10 to the minus 8th multiplied by 1 times 10 to the 9th. That's all the stuff on top. So I hit enter, and then I divide by 100. I hit enter again, and I get 0.121. Where'd it go? 0.121 nanometers. Okay. So we'll see if I got the right answer here. Yeah, so that is correct. The correct answer is 0.121. Okay. All right, so that's number 32. So the next one I want to do is 35. Okay, so this is a similar type question, but this one has the squared stuff in there, so we need to take that into account. So we're going to start with the number that we're given, the 9.7 times 10 to the 4th, and square miles. Okay, now this one doesn't have the conversion factor written, clearly in the problem statement. So you may have had to do a little research to figure out, how many kilometers are in a mile, or vice versa. And so that may be what's tripping some people up. But what I can tell you is that in 1 mile, so I want miles to be on the bottom because that should cancel, and I want kilometers to be on the top. All right. And so here's the conversion factor. 1 mile is 0.6214 kilometers. Okay, a kilometer is less than a mile. So, but that only got rid of one of the miles, right? This is miles squared, or square miles, right? So I got to do this again, but it's the same conversion factor. So the 0.6214 kilometers over 1 mile. Okay, so now the other miles canceled, you can see that. And now I've got kilometers and kilometers, so it's going to be in square kilometers, right? So now I'm ready to, I've got the units that I want, so now I'm ready to go ahead and put in the answer part. Okay, so now I just go ahead and plug in the units right there, kilometers squared. And so now you just use your calculator to do the math. So 9.7 times 10 to the 4th times 0.6214 times 0.6214. I hit enter, and I may have done something wrong. Yeah, I think I've done some math wrong in here somewhere. Let me try it again. So 9.7 times 10 to the 4th. Oh, you know what? I got these. I'm glad I got this all mixed up. So these two are just the opposites. So let me pull that out of there. And I'm glad I made this mistake. So then you can see this is a common error. You get the numbers mixed up. So 1 kilometer is 0.6214 miles. Yeah, that's my bad. And I apologize for if I confused anybody. I did say correctly that a kilometer is less than a mile. And so this is the equivalency that shows that. So a full kilometer is a fraction of a mile. So a kilometer is less than a mile. And this is a common error. Whenever you're using conversion factors, yeah, it's sometimes easy to get those things mixed up. All right, so now let me do the math. The units still cancel the way they should. So 9.7 times 10 to the 4th divided by 0.6214, enter, divided by 0.6214, enter, and you get 2.51 times 10 to the 5th, which is right here. So 2.51 times 10 to the 5th. Okay? So we'll show the answer, and that is correct. So again, I apologize, but it's actually, kind of a good, a good mistake, because it allowed me to show a common error when working with these conversion factors. All right, so that's number 35. So now we'll go to the next one that I want to do. Okay. For some of you that are getting it wrong, let's see, maybe what you're doing here. Yes, so you can kind of see. I'm not sure what's wrong with this one here. You may have something in the setup here that looks like the right work. And this one, whoever did this one, you just got it flipped for that second conversion factor. Okay. All right, so that was number 35. Number 36. Let's look at this one. I want to look at this one too. All right, so okay, so what we're focusing on in this particular session is lesson 2, which a big part of that was the conversion factors, using conversion factors. So we're doing several problems like that. So this one says a student needs to run 3.2 kilometers to get to school. If the student can run 5.5 miles per hour, how many hours will it take them to get to school? Okay. So again, when you start these conversion factor type problems, they're called dimensional analysis. That's another name for it. You always begin with a number that you're given that's not a conversion factor. Well, if you ever have units of something per something, like this case, 5.5 miles per hour, that's a good sign that it's a conversion factor. So we're not going to begin the calculation with that number. We're going to begin with the number that we're given that's not a conversion factor, which is this, the 3.2 and units of kilometers, okay? And so now the first thing I got to do actually, because what we're looking for is we got to get rid of miles. Well, I don't have units of miles yet. So I got to, once again, just like the previous problem, I got to convert kilometers into miles, and hopefully I'll do it correctly this time. So there are 0.6214 miles in 1 kilometer. All right, so now kilometers cancel. Okay, so now I have units of miles. Okay, and so now is when I'm going to use the conversion factor to cancel my units of miles and have leftover units of hours. So let me show you how to do that. So it's 5.5 miles per hour. So another way of thinking about that is in 1 hour, this person can run 5.5 miles. So remember, with conversion factors, you can flip them. You can put whatever you want to on the top and the other part on the bottom. You arrange it however you need to arrange it to get the units to cancel properly. So in this case, I needed miles to cancel. So instead of showing it as 5.5 on top with 5.5 miles on top of 1 hour on the bottom, it's still an equivalency. It's still true. In 1 hour, this person can run 5.5 miles. So I put the 1 hour on the top and the 5.5 miles on the bottom so that I get miles to cancel and I end up with units of hours. Okay, so now you got the units that you want. So now you're ready to just calculate it. So 3.2 times 0.6214, hit enter, divide by 5.5, hit enter again, and you get 0.36. Where's that at? 0.3, there it is, 0.36 hours. Okay. All right, so I think that that's the right work with the correct unit. So I'm going to show the answer, and that is also correct. Okay. All right, so that is number 36. Okay. All right, so again, if I'm going too fast or if anybody has any questions on these, just go ahead and stop me. Take yourself off mute and ask your question, or put something in the chat box. I'll pause for a minute. The next one we're going to look at is number 43. So one thing about these, so you'll notice here, like in number 43 and in 40, well, particularly because we're going to do 43, that these numbers that are in this shaded box, that means that your actual problem may not have the same number. The method that we're going to use will be the same for everybody, but the numbers that you're working with may be a little bit different. Okay, so in this question, right, we are asked to calculate the rate of drip in terms of volume of the saline solution per hour to deliver 4 units of this insulin per hour. Okay, and what we have is we have a mixture where there's 500 units of insulin in 250 milliliters of the saline. So this one is a little different in that I don't have, what's called scaffolding. What we did in those previous 2 problems, where we just kind of click and drag the numbers and the units over into the calculation, that's called scaffolding. This question is more, can you do it on your own without the scaffolding? So let's see. So, but the technique is going to be the same. We're going to start our calculation with the number that we're given that's not a conversion factor. Okay. Well, it's a little harder to pick out in this one, because what we need, is 4 units per hour. All right. So that's going to be the thing that we actually start with. Okay. And the other thing that we can, let's see. So we've got 4 point. So 4.00 units in 1 hour. Okay, so I've already got part of the units that I need. I've got the hours in the denominator just like I need it. So that should be good. And I want to make sure that I don't, unintentionally cancel that out. So what I need to do is I need to get rid of units and I need to get milliliters. Well, what's nice is I have an equivalency that gives me that conversion right there. In 250 milliliters, there are 500 units. Okay, so now units cancel, and I have units of milliliters per hour. Okay, so I have the units that I want, so now it's just a matter of plugging in those numbers in your calculator. So let's do that real quick. So 4 times 250, which is 1,000 if I'm not mistaken. Yep, and I divide that by 500. Okay, and that gives me 2. So that should be 2, and again, milliliters per hour. So this drip needs to be at a rate of 200 milliliters per hour. All right, so we will use the mouse and go to, I think that should be good. So, okay, yep, clear all that away. All right, so we got that one correct too. Okay. All right, so now that was 43. So the last one I want to do is 44. And then, so if you guys have any more questions for me, go ahead and start thinking of them and submitting them in the chat box, because this is the last one that I have planned to do. So this is a density question, all right? So it says that we have a liquid in the lab and it has a density of 1.24 grams per cubic centimeter. What is the mass in grams of 254 milliliters of the liquid? Well, all right, so we're gonna begin with the fact that we have a number, the 254, okay, and it's not a conversion factor. A density is most often used as a conversion factor, a way to convert between mass and volume, right? So you begin the calculation with the number that you're given that's not a conversion factor. So that's the 254 milliliters. Okay, so the first thing I really need to do is I need to reconcile the fact that volume here is milliliters, volume in this density is cubic centimeters. So remember that it's just it's 1 to 1. When you're talking about a liquid, or really anything in the metric system, a cubic centimeter is the same volume as 1 milliliter. All right, so let's go ahead and make that clear in this particular problem. So 1 milliliter that are on the bottom is 1 cubic centimeter, right? So now I can use the density, because it says that in 1 cubic centimeter, there is 1.24 grams. So again, I just chose which number and unit to put on the top based on what units I needed to keep and what units I wanted to cancel. So 1.24 grams is in 1 cubic centimeter. That's really what a density means. Okay, so now I have the units that I'm looking for. It says, what is the mass? Well, grams are a unit of mass, and that's what I'm in units of grams. Okay, so I can just plug all that into the calculator. So I've got 254 times 1.24, and you get 314.96, but we'll round that because I've got 3 sig figs. So we'll say 315, which is right there. Okay, show the answer, and that one's correct. Okay. All right, so that's how you do number 44. All right, so we got a question in the chat box here. It says, I have a question about the tools we need for lab. I purchased the kit from the bookstore, but I'm unsure of the material needed to purchase from the website. Okay, so yeah, to answer that question, so the website is where you get the chemicals. There's a few chemicals that you're gonna need eventually to do the labs. Now, the first few labs, you won't need any of those chemicals. So you can go ahead and get started and do, at least the first 3 labs. But it's called Home Science Tools, and the link is in the syllabus. Okay, it's actually in the introductory assignment for the course. It was there as well. Okay, if you have more trouble finding that what I've done is I've created what's called a wish list with this company called Home Science Tools, and if you click that link, it takes you right to this wish list, and you can add those chemicals into your cart, and you can purchase the chemicals. It's about $20 worth of chemicals, 4 different chemicals that you should purchase. Okay, so if you have more questions about that, feel free to email me, and we can we can talk about it some more, but that's what we're talking about. You get the kit from the bookstore, but you also need to order those chemicals from that website, Home Science Tools. Okay. All right. So that's all that I had for you tonight. What we'll do on Thursday, just to kind of keep everybody on track. So there's 7 units, right? And there are 15 weeks in the semester. So you should schedule to finish a unit about every 2 weeks. Okay. So we're finished with 1 week. So you want to definitely make sure that you finish up unit 1, including the quiz for unit 1 this week, this coming week. Now, what I recommend, so you clicked on the link and it took you to the library website. Okay, well, I'll have to double check that. That's odd. You shouldn't do that. I'll have to check that. Maybe you and I can talk offline, maybe over the phone or through Zoom or something. But I will check that link. Okay. All right. So again, talking about the sort of the scheduling of things. Unit 1 is the it's an introductory unit. So the next 2 units, units 2 and units 3, are typically the longest for students and 2 of the more challenging kind of units for students. And so if you can gain a little bit of time here in unit 1, then you're going to allow yourself a little bit more time to finish up units 2 and 3. So I think that if you could shoot for getting unit 1 done by like Thursday, that would probably be the best if you can. It's not, going to be a requirement or anything. I think that I've set the due date for the unit 1 quiz to be done by next Sunday at 11:59. But again, my recommendation is to try and get it done a couple days early, just so you can have a little bit more time to work on units 2 and 3, because units 2 and 3 are, in my experience, they're longer. There's more material there. They're a little bit more challenging. So you may want to give yourself a little bit more time. Okay. All right. So that's my sermon about scheduling and things like that. All right. Does anybody else have any other questions for me? Thanks for hanging in there. And again, don't hesitate to contact me outside of this session, with an email or with a text message, if you need any help for anything. Going once, going twice.
I just have a question about
Yeah.
like the test. Is stuff on the test found in like the lecture videos you have in those notes, and then like how much is from the book that's going to be on the test?
So the book, you mean like the textbook, OpenStax?
Yeah, like yeah.
Okay. So that is not a big source of quizzing or testing material, the book.
Okay.
Right.
Okay.
I think the book is good, but I don't tend, I don't give away a lot of what I'm going to put on the quiz. What I think is this: I think if you do the homework assignment, you do the extra practice problems, you've done the lessons, you do the practice quiz. That's definitely going to give you a better flavor about what to expect on the quiz than what you see in the book.
Okay, thank you.
No problem. Okay, anybody else? Going once, going twice? All right, hope everybody had a great weekend. Hope you have a great weeks, and we will talk to you again soon. Thanks.